talk about SOLIDWORKS electrical in regards to routing and electrical harnessing. So how to kind of step up from a wire route into a cable route, and then finishing up with a harness route. So our demo set today is going to be this microbrew example. So a coworker is very into crafting their own beer and has this set up at home. So we can see that there's a control system that's monitoring 3 pots here. Each controls its own temperature, each controls water inflow, and everything is wired up back to this control box. So we can see that we have a couple pumps, we have cables coming down, as well as internal wires into our microbrew. So we're going to use that as our example, and we're going to look into these 3 areas, so wires, cables, and harnesses, and how each one is perceived differently inside of electrical, or is created differently inside of SOLIDWORKS electrical. So starting with wires, we can see in our example here that our panel box is going to contain pretty much full of wires. We'll have terminals or termination points that will run into each circuit breaker or relay, as well as our terminal block. And we want to be able to route those wires as a point-to-point connection. Inside of SOLIDWORKS, we know we can make this panel box, we know we can make these connectors. It's a matter of how do we get those wires to show up accurately to what we're designing. All right. So a wire, in terms of everything, is just a point-to-point connection. So we're trying to connect electricity between 2 connection points. The way we do that in SOLIDWORKS electrical is using our Multiline Schematic, where we're going to draw a wire style from one termination point, in this case fuse pin 2, or our output of our fuse F1, running into our 50 amp shunt into pin 1. So we can see that we have a 14 gauge black wire, and this happens to be the 7th 14 gauge black wire that we use inside of our project. All right. Once we're, actually I'll jump into electrical real quick here just to kind of show some wires internal to a project. So as we're dealing with different connection points, we can start to see how wires are drawn inside of a schematic. If I zoom out, we can see more of these. So most of our wires are staying internal to our panel box. We've created a numbering scheme based on that gauge and the color, as well as just a counter to make sure that every wire's number is unique. Over on our external, outside of our cabinet, see we still have our wire numbering, but we also get some different coloring and different naming when we get into cable cores. Right. So we'll talk about cables in a little bit, and we'll focus on our wires right now. So inside of electrical 3D, so inside of SOLIDWORKS now, we have the ability to route wires and pick if we want it to be a SOLIDWORKS route, which means it's going to have a look and feel of a SOLIDWORKS model. It'll have diameter, it'll have curvature, or a 3D sketch route, which would be a little bit quicker, but it doesn't give us that actual geometry. It's giving us 3D sketches in the path that the wire would take. A 3D sketch route does give us all the length properties that we would want, and it would show us if we have too many wires going in one spot, or trying to pass through one duct. But this does give us a quick idea of where our wires are going to and from. And right now I've sped this up, so this isn't live, this is a video that I sped up just to show you the process that SOLIDWORKS takes, and that it finds a point-to-point connection for that wire, and that's that yellow line that appears, and it's showing that as its fastest path. And then based on a pathway that I've defined, it actually snaps the wires still in the shortest path, but on that pathway to get from point A to point B. All right. So inside of our model, we can start to see how these wires look to the point that they run into our connections. You can see that they actually terminate at a terminal. They're using these pathways that I've defined to say, all right, I want to cross into my panel box from the door at this point, and we can use some of our zip ties to keep everything organized internal to our panel box. All right, so our pathways run through those zip ties to make sure that our wires are going to stay organized. All right. Next, I want to talk about cables, so how we create them, and then what they look like in 3D. So if we want to include the wires breaking out of that cable and running into terminations, or we just want to show that cable in 3D space without the need for the wires. All right. So in our example here, we can start to see that we have cables that are running out of our panel box and running into each of the tanks and our pumps. We just need a way to better define that inside of our SOLIDWORKS model. All right. So we've modeled up our entire brewery here. We have all the components that we would need, including our plugs and any mounts that we want to use to try to keep these cables contained. We're going to talk about actually routing these in 3D space to help get lengths and understand where cables are going to go to and from. All right. So a cable is similar to the wire, except we're going to have multiple wires that are acting as cable cores. So we're assigning individual cable cores to the bulk that is the cable. All right. So an example here, we would see 3 wires that are now turned into a cable core. I showed you earlier that gold color. So we can see that they still have wire properties, but now they belong to that cable. And our cable name here is W4, and that's the core description. So our blue matches our green and our yellow. We can also describe these cables as a single line diagram, where we now can show cable W4 as it goes between our XLR1, or our XLR plug or connector, going into our boiler kettle, so our K1 component. And ultimately, what both of these are showing is a cable with cores inside of it, so with copper inside of the cable, and where they terminate. So we're going to see that terminal 1, 2, and 3 on XLR1 become components, or become termination points for these wires inside of our detailed cabling. Same with our boil kettle. We can see that it has 3 terminals that are being terminated on each of these wires. Right. How that looks inside of SOLIDWORKS electrical schematic is if I were to take wires that are going between our power receptacle and our input power plug, so both external to our panel box, where we're trying to route out of our panel box into the wall. So we see that we have 4 wires that are going to be acting as our hot, our neutral, and our ground, and we want to associate that to a cable. And the way I do it from the schematic is I highlight the 4 wires that we're talking about here. I can right-click, and that brings up our context menu, and I can associate those cable cores. All right. This brings up our associate cable core window. From here, I can see what cables I'm planning on using internal to this project. I can also go find a new cable. For this, I want to define it as my user-defined power cable. I'm going to make sure that my ground is matching my ground first. I want to make sure that protection matches my protection wire style. I'll go ahead and associate those. And then for my remaining wires, I'm just going to do a group selection and go ahead and associate those cable cores. All right, I'll go ahead and hit OK. And now what we see, I'll just move these over a little bit, is our cores for our hot and our neutral are now associated to cable W9, and internally they are a black wire. And then our ground, which ends up being a green-yellow wire, turns out to be part of cable W9, but has a different differentiator as the ground. What this looks like inside of 3D space is we take each of those cables, and this time around we're routing cables instead of wires. And similar options, we can do it as a SOLIDWORKS or as a sketch, and we can do it as splines or lines, so some more 90 degrees versus some curvature. And we can select the components that we want to route these cables to. And we only need one side of it. So I'm going to select these 6 cables. And you can see my power receptacle there is going to be one of them, and we'll dive into that a little bit deeper. But once I hit route cables, it's still going to create that yellow path of the wires. So it will route each of those cable cores first, and then it's going to bundle them into a cable. So it's showing what the path is for the cores, and then it's realizing, all right, I have a pathway and I belong to a cable, so it'll lock that cable in. And when we look at this in 3D, just zoom out a little bit here, we can start to see that our cables come out of our connectors. They follow the path that I've generated, and for these ones, we can see that they come down and route into our pumps. So these are providing our pumps power. So they'll come right down and go into the pump. Same with on the table. We'll come down, split, and now these become our sensors. All right. On the slide, I was saying that a cable can have a single connection point or multiple wire connection points. So if I were to just hide this back shell, we can see here that my power cable that I generated has my 3 black wires as cable cores, as well as my 1 green-yellow that goes to ground. All right. Where some of my other cables might only have 1 connection point, so just one insertion point that's going to say, yep, this is a cable. I don't need to worry about the internal wiring internal to the back shell. It's just the difference between having wire connection points inside of a cable route versus just having the 1 cable connection point. What this looks like as far as a connector goes is our connector will have 1 cable connection point, or EW cable, as well as, for this example, 4 other connection points internal to the model. So I can see that I have connection 0, 0, which is related to my first terminal, my second terminal, third, and then that's my ground, 0, 3. Right, so that's how these 2 link together. All right, and I want to wrap up, so taking it one step further and generating a harness now. So how do we create them? How do we route them inside of 3D? So create them in 2D, route them in 3D, and then what can we do once that's in 3D? So how do we flatten it, create a drawing, or generate any reports based on that? We will take one more slide here. So a harness is a group of wires or cables. So individual wires, individual cables that are using the same path. So we want to route them together. We might zip tie them together. We might put them into a sleeve and then create the breakaway where necessary. All right, so they're going to share this routed path for some distance. We don't want to harness something. There are 2 items that are going to go opposite directions. We want to make sure that they're going to be bundled together to their endpoint. And a harness works slightly different than a wire. So the wire becomes its own part inside an assembly. A harness and a cable actually generate their own sub-assembly inside of our project. All right. So we create this harness inside of our schematic by selecting the components that we want to be in the harness. All right. So if I go into schematic and I go to my single line diagram, if I select a couple components, including the cables that connect them, and I give it a right click, I can add or remove these components to a harness. And you can see that there's physical components associated with them, as well as the cable, as well as the line, and that's going to show us how we're connecting to and from. Right, so we can say add to this harness, and inside of H1, we can see we have our two wires, or our two line diagram items, our two cables, cable W2 and W3, as well as our four components. So the connections inside of, or connected to our panel box, and then the heating elements at the kettles. Once we have our harness assigned, the routed harness will route inside of the 3D space, similar just as the cables did, but you'll start to see that we'll share the pathway. So I'm just going to hide our cable assembly real quick. So we can start to see our harness assembly now. Wherever our cables meet inside of our harness, they're going to generate the harness look. All right, so we can start to see that our harness still follows the path, just like our cables did. However, when the cables need to split out of that harness, it's going to generate its own path. So this is the last common area that we're sharing between these two cables. So my orange cable is going to split out to kettle 3. My green cable will continue behind kettle 2 and run into kettle 1 here. All right, so we can start to see these different wires, or these different colored cables that join in the harness. Once that harness is routed, we can actually isolate it. So I see that I have a EW routing assembly harness generated. And what happens in electrical is that it hides our parts that are used inside of our assembly and generates the subassembly with copies of those parts. So I can start to see that my connectors become components inside of the subassembly. The cables that I generated are also components inside the subassembly. Using an electrical feature, electrical routing feature, I can flatten this route. And what a flattened route does is it isolates that subassembly that we generated. If I were to rotate around here, I'll just hide those planes, I can start to see this is what the subassembly looks like in 3D space. So I still have my connectors with my cables running up to them. I still have my harness with the split out, as well as my connectors that were up at my panel box. All right, so this is a powerful tool to be able to see where connectors are in 3D space and how we're routing to and from them. But to make a drawing of this, it's not very clear. I guess it's clear, but we don't have all the pieces or all the information that we may want. So what I can do is flatten this into an annotation view. And that generates this layout that it definitely changes our scale, but it makes it an easier understanding of what cables are being harnessed, what connectors we're using for that harness. All right. Once we're in a flattened, so an annotated flattened view, this is actually a configuration, I can edit this route and I can clean it up a little. So maybe if I wanted to fan out a couple of these wires that are hiding behind our connector, I can go ahead and adjust them so they're a little bit more visible, that we have a black, red, and green wire. Go ahead and apply that. Maybe I want to move just these connectors so we can see those wires behind. So I'm still in SOLIDWORKS, so I can rotate as needed and drag just like I would inside of a SOLIDWORKS model. And once I'm happy with how this looks, I can go ahead and generate a drawing for it. So for my electrical tab, I'll hit flatten route again. This time around, I want to create an electrical bill of materials as well as a circuit summary, so what cables and wires I'm using. And what we'll generate here, just throw this up top, is a detailed view of our electrical harness now. So I can see that I have a conductor, so a 10-gauge conductor cable that we're calling W2 from our schematic. It contains a black, blue, and red wire, and these are routed just under an inch in this example. So we're routed from this connector to this connector, and those connectors are linked to our bill of material on the other side. So I can start to see that I have 2 power box connectors, which were over here. Item number 1 based on the balloon. And I have 2 3-prong large power conductors that were going into my panel box. And then I have the overall length of all my conductor wire. So for my 10 gauge, I have 163 inches, and for my 10 gauge, which was my orange cable, which was a little shorter, I have 135 inches. All right, what I can do once I have this information, one thing I can do is generate I can go ahead and throw marks onto this view. So I can link these back to my schematic. I can also create a project drawing which will push back into my schematic. So I now have this new drawing. Oh, my scale's a little off. That's okay. I now have this new drawing in my schematic that's directly related to my SOLIDWORKS model. So I have each component as needed. I have the length, and I have my bill of material tables in there as well. Other things we can do with that harness is we create our drawing, we create our plan. We can generate reports from my project tab, say reports, and we can start to see the cable cores of our harness. We have cables in our harness, and then the bill of materials. So I'm going to generate drawings based on those cables and bill of materials. It'll generate 3 new reports for me, and I can start to see that my cable W2 has 3 cores, black, blue, and red. It starts at my connector J3, pin 1, 2, and 3, and goes out to my kettle 1, connector J1, pin 1, 2, and 3. Here's the cable core that it uses, or the wire number that it used, the code that it uses, and then its length, and that's going to be based on our 3D. So you can see that each of our individual cable cores has a different length based on where it's being terminated, both at the J3 and the J1 connectors. The cables that we used is going to be a similar table to our SOLIDWORKS. So the cable number, the manufacturer, the reference, description that we gave it, and then where it's going to and from. And again, the length, this time in meters. So we can always adjust that to the inches. And finally, our bill of materials for that harness, which we called H1. So our 2 connectors, actually our 4 connectors, 2 of them being from Bryant and the other 2 being from J. Eaton.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.